Hello everyone, am I audible to you? Am I audible to you everyone? Yeah. So let's wait for 2 to 3 minutes so that others can join. Hello Stephen, good evening. How are you? सर इस बार की कट ऑफ क्या होगी? एग्जाम होने दो फिर पता चल जाएगा। ज्यादा मतलब जो लास्ट ईयर कट ऑफ गई थी उसी के आसपास ही रहनी चाहिए। तुम ये बताओ कि एग्जाम की प्रिपरेशन कैसे चल रही है? हाउ योर एग्जाम प्रिपरेशन इज गोइंग ऑन? कट ऑफ की चिंता मत करो, सिर्फ पढ़ाई पे फोकस करो। गुड। टेस्ट सीरीज ज्वाइन करी? आई मीन टेस्ट सीरीज दे रहे हो? Let's wait for good 2 to 3 minutes so that others can also join. करे रेंडर होगी, ओके, नाइस। एक्चुअली क्या होता है कि हम थ्योरी जब पढ़ते हैं तो क्वेश्चंस की प्रैक्टिस करने के लिए टेस्ट सीरीज देना जरूरी होता है, राइट? जब हम टेस्ट सीरीज देते हैं तो हमें एग्जाम का एक प्रेशर रहता है जो एक्चुअल अगर आप टेस्ट जब आप एग्जाम में बैठोगे ना तो वो आपको हेल्प करेगा क्योंकि आपने पहले से ही एग्जाम का प्रेशर मीन्स टाइम का प्रेशर जो है वो देख रखा होता है। आपको पता चल जाता है कितने टाइम में एक क्वेश्चन को करना है और किस तरह से कौन-कौन से क्वेश्चंस को किस तरह से अटेम्प्ट करना है। दैट विल हेल्प यू अ लॉट इन द एग्जाम। टाइम को मैनेज करना आना चाहिए उसमें। और कौन-कौन जॉइन हुआ है? आई थिंक 3 पर्सन्स हैज़ बीन जॉइन्ड। एनी अदर क्वेश्चन यू वांट टू आस्क अबाउट द एग्जाम और प्रिपरेशंस? ओके, नो आई थिंक देयर इज़ नो एनी क्वेश्चन। ओके, तो बढ़िया चल रही है फिर सबकी प्रिपरेशन है। सर ईएमटी और मैकेनिक्स का कुछ पोर्शन छोड़ सकते हैं। डिपेंड करता है कौन सा पोर्शन छोड़। ईएमटी का देखो, इलेक्ट्रोस्टैटिक्स और मैग्नेटोस्टैटिक्स ये दोनों तो काफी अच्छे से कर लो, इनको मत छोड़ के जाना। थोड़ा इजी है, थोड़ा सा मतलब काफी मोस्ट स्कोरिंग टॉपिक्स होते हैं, इनको तो कभी मत छोड़ना। मैकेनिक्स इन द सेंस मैग्नेटिज्म वाला, मैग्नेटिज्म वाला मतलब इलेक्ट्रोस्टैटिक्स हो गया। ओके ग्रेट। अभी टाइम पड़ा है, अगर आप कवर कर सकते हो मैग्नेटिज्म मैग्नेटोस्टैटिक्स कवर कर लो, अगर कर सकते हो तो। टाइम है वैसे अभी, आई थिंक। राइट? सो कोशिश करो कि कोई टॉपिक छोड़ना ना पड़े, बट अगर छूट जा रहा है तो कुछ कह नहीं सकते, राइट? और मैकेनिक्स का कितना करा है? मैकेनिक्स के लास्ट ईयर कुछ क्वेश्चंस आए थे, आई मीन टॉर्क वगैरह से रिलेटेड। टॉर्क, एंगुलर मोमेंटम एंड स्ट्रिंग पुली सिस्टम, और ये जो टॉपिक्स होते हैं काफ़ी अच्छे होते हैं। क्वेश्चंस इससे बनते हैं ज़्यादातर। थर्मोडायनेमिक्स और मॉडर्न फिजिक्स काफ़ी अच्छे से करना भाई। पढ़ तो पूरे लिए रिवीजन बाकी है भाई, रिवीजन साथ-साथ करो। चलो अच्छा है। क्वेश्चन प्रैक्टिस तो इम्पोर्टेंट है। कभी-कभार क्या होता है कि हम थ्योरी पढ़ कर चले जाते हैं, बिल्कुल अच्छे कॉन्फिडेंस में होते हैं, बट वहाँ जाके क्वेश्चन बनते नहीं है ना, तो क्वेश्चन प्रैक्टिस भी इम्पोर्टेंट है। ओके। कहाँ से हो आप? फ्रॉम वेयर यू लिव? सर क्या इनर्शिया और सेंटर ऑफ मास छोड़ सकते हैं? भाई सेंटर ऑफ मास मत छोड़ना भाई। सेंटर ऑफ मास मत छोड़ना। आई मीन डेरिवेशन जो होती है ना उसमें, सेंटर ऑफ मास में, आई मीन वो आप छोड़ सकते हो, उसके रिजल्ट याद कर लेना क्योंकि वो काम आते हैं। और इनर्शिया के जैसे अगर आपके स्फीयर का इनर्शिया कितना है, 2/5 mr स्क्वायर, और राइट, होलोस्फीयर का, हेमिस्फीयर का, उनके जो मीन्स जो स्टैंडर्ड रिजल्ट्स हैं उनको याद कर लो क्योंकि वो डायरेक्ट यूज हो जाते हैं। कभी कभार आपको काइनेटिक एनर्जी, कोई रोलिंग स्फीयर होता है तो काइनेटिक एनर्जी निकालना आ जाता है, तो उसमें आई का यूज होगा, हाफ आई थीटा डॉट स्क्वायर, तो वहां आपका यूज होगा। एक बार बताना मेरी वॉइस ऑडिबल है क्या, क्लियरली ऑडिबल है? इज माई वॉइस ऑडिबल क्लियरली? ओके ग्रेट। आदित्य बागरा, कहाँ से हो आप? मैं हरियाणा से हूँ वैसे तो। जयपुर, ग्रेट। सर 50 नंबर पे रैंक अंडर 200 आ सकती है या सेफ स्कोर है? 50 नंबर पे देखो, रैंक बहुत ज्यादा वेरी करेगी उसमें। अगर एक दो नंबर भी ऊपर नीचे होगा तो उसमें बहुत ज्यादा रैंक वेरी करती है 50 नंबर के आसपास। ठीक है, तो रैंक का कुछ कह नहीं सकते क्योंकि एक दोस्त था मेरा तो उसकी रैंक एक्सपेक्टेड थोड़ी 200 से कम थी, बट 200 से ज्यादा ज्यादा मीन्स ऊपर चले गए, तो दैट्स ऑल। रैंक ज्यादा वेरी करती है इन नंबर्स के बीच में, जहाँ पे जो क्वेश्चन का होता है ना, जहाँ पे पीक क्वेश्चन कहते हैं वहां पे ज्यादा रैंक वेरी करेगी। सर प्लीज बताइए बेसिक से लेके प्रिपरेशन कैसे करें? क्यूट। सर आपने कितना पढ़ लिया आपने? कितने टॉपिक्स कवर करे? आई मीन देखो, मॉडर्न फिजिक्स जो मोस्ट इंपॉर्टेंट होते हैं ना, हाँ आ सकता है। देखो डिपेंड करता है आपकी कैटेगरी कौन सी है, जनरल है, ओबीसी है, और आराम से आ सकता है। आई मीन अगर आपकी रैंक 150 से कम है या 200 से भी कम है, चल जाएगी। अगर आप ओबीसी, जनरल में भी आ जाती है, ऐसी कोई प्रॉब्लम नहीं है। मेरी रैंक 90 थी। मेरी रैंक 90 थी तो मुझे कानपुर भी मिल रहा था, आई मीन बॉम्बे को छोड़ के सब कुछ मिल रहा था। मैंने आईआईटी दिल्ली प्रेफर किया। जनरल गुड, आराम से मिल जाएगी। अगर 200 से कम है थोड़ी सी तो डोंट वरी, चिंता मत करो, रैंक की चिंता मत करो, बस पढ़ाई पे फोकस करो। देखो कुछ सब्जेक्ट्स, हाँ मैं प्रिपरेशन के बारे में बता रहा था, तो कुछ सब्जेक्ट्स हैं जैसे मॉडर्न फिजिक्स है, ईएमटी है, थर्मोडायनेमिक्स यानी काइनेटिक थ्योरी ऑफ गैसेस, और थर्मोडायनेमिक्स और मैकेनिक्स। ये जो चार टॉपिक्स होते हैं ना, इनमें ज्यादा क्वेश्चन, या आई विल आई विल ऑल्सो मीट यू। इनमें जो ज्यादा टॉपिक्स होते हैं इनसे ज्यादा क्वेश्चन बनते हैं। और बाकी जो सब्जेक्ट है, वेव्स एंड ऑसिलेशंस, आई मीन थोड़े कम पूछे जाते हैं। बट अगर आप इन चार सब्जेक्ट को कर लोगे, अच्छे से करना, मतलब एक भी क्वेश्चन मत छोड़ के आना, काफी अच्छे से प्रैक्टिस करोगे तो मोस्ट प्रोबेबल चांस आपका हो जाएगा। ऐसा नहीं है कि बाकी सब्जेक्ट्स को छोड़ देना, बट ठीक है, इन चारों को अच्छे से करके जाना। आई थिंक आई विल गोना टू मीट यू देयर सून। या बिल्कुल मीट करेंगे भाई, आईआईटी दिल्ली में आना तो मिलेंगे बिल्कुल। So let me give my introduction. I hope you have seen my premium video, but that's all. Let me again give my introduction. So my name is Nitish. आपका कोई पर्सनल चैनल है क्या? मेरा पहले था, बट अभी मैं उसको कंटिन्यू नहीं करता। दैट्स दैट इज पहले था। So myself Nitish, I am from IIT Delhi, currently doing masters in physics. I have correct COT PG examination and just, and also I am in the top 1% in the exam conducted by DU. I mean, they conducted their exam. Okay, आपका कोई okay. So let us start again. Anything you want to ask about the preparation or कुछ भी जनरल क्वेरी फिजिक्स से रिलेटेड या कोई भी सब्जेक्ट से रिलेटेड? अदरवाइज वी विल स्टार्ट नाउ. I am a friend of Indu Rekha Kundu. Okay. Okay. So I think we should start, right? So are you ready? Let me share my screen. Hmm. Okay, is my screen visible to you, everyone? Just comment that out. Is my screen visible? Yeah. Okay, great. So let's start our session. So as I told you, my all India rank was 19 IIT-JAM physics. I cracked the JEST exam as well as COT PG exam. I'm in the top 1% in the NGP exam, right? This was conducted by the Indian Association of Physics Teachers. I did my BSc honors from Guru Jambeshwar University of Science and Technology. Okay, so let's start our first question. So here is our first question. It says, let u of x and y equal to x plus half of x square minus y square be the real part of the analytic function fz. Okay, you need to find the complex imaginary part of the fz, where z is equal to x plus iota y. Okay, this is the question from the complex analysis. You have studied the CR equation, I mean Cauchy-Riemann equations, right? Let me see the comments as well, so that I can understand whether you are understanding me or not. Okay, so this is the concept from the Cauchy-Riemann equations. Uh, in the complex analysis, we take fz, any function that is a function of z. It can be represented as two parts. That is, u is a function of x and y. That is the real part, right? Plus iota as v as a function of x and y, right? Where u xy is the real part of the function, right? And vxy is the imaginary part of the function. So here what we need to do is we need to find the v of xy. Okay, screen not presenting. Okay, wait a second. What happened? Okay, let me again share my screen. Wait a something. Yeah, is it visible now? I think is it visible? It is visible, right? Yeah, now it is visible. Great. So let me start again. Sorry for the interruption. So the first question is, let u xy equal to x plus half of x square minus y square, right? Is the real part of the analytic function. it is given that this real function is the analytic part of the fz of the complex variable z equal to x plus iota y. So we need to find the imaginary part of the fz, right? So as you can see from the question, this is the concept of there we use the concept of the Cauchy-Riemann equations, right? I think everyone has studied the complex analysis. So there we study the concept of Cauchy-Riemann, right? In that concept, we learn that any function, any complex function can be represented as two parts. That is u x y plus iota v x y, where u is just the real part of the function and v is the imaginary part of the function. What this question says is we are given with the u. What is u? U is the real part of the wave function, right? We need to find v. So how will you going to find the value of v? How you will going to find the value of v? Okay, no one is commenting out. So as we know, the Cauchy-Riemann says is del v upon del x, sorry, del g upon del x is equals to del v upon del y, and del u upon del y equals to minus of del v upon del x, right? As we all know about this Cauchy-Riemann equations, right? So what this says is the derivative of u with respect to x is equals to derivative of v with respect to y. That is the partial derivatives. And similarly, derivative of u with respect to y is equal to minus of derivative of v with respect to x. And this Cauchy-Riemann equations is only used when the function is analytic, right? Here in the question is given as function is analytic in the complex variable, right? In the complex plane, we can say. So we can use this Cauchy-Riemann equations. Okay. So let's do the solve this first equation. Let's do the differentiation of u with respect to x. That is the partial differentiation. So what we get is 1 plus x, right, is equals to del v upon del y. And partial derivative of u with respect to y, what we will get? Let's do the partial derivative of u with respect to y. We get only minus of y is equals to minus of del v upon del x. Okay. So these two equations are we get. Now we need to solve for v using these two equations. So let's solve first these equations. So we get, let's integrate the first equation. We get v is equals to integration of 1 plus x del y, right? And from here we will get v is equals to integration of y del x. As we are doing the integration with respect to the y, we will take x as a constant variable, right? So we get v equals to y plus xy and some function of x. We don't know it, right? Y. By comparing this part and this part, we get v. What we will get? We will get v is equals to y plus xy, right? Because this here function is only of x, it will not contain any y function. If we see here, there is no any function of x alone, so fx can be taken as 0. If we see here, we want a function of y, right? This statement says that there should be any function of y, and here we see there is a function of y alone, so we take y as f of y, and we will get v as a y plus xy. Okay. Any doubt till now in this question, or you want to ask anything about this concept? Are you getting it? Is first year okay? We are getting some comments around here. A little bit, okay. Sorry to interrupt you. Wait. पर मैं मैथमेटिक्स के बेसिक और अच्छे से कर सकता हूँ. आई मीन और अच्छे से मतलब लिटिल बिट. आपने मैथमेटिकल अच्छे से नहीं पढ़ा है. Is first year is enough to crack? Yeah, 1 year is enough. I mean, even if you are consistent in your studies, so I mean, 6 months is also enough for the cracking the IIT-JAM exam with good score. If you not able to do this question, I mean, you have to do the mathematical physics. Okay, you have to practice a little bit about mathematical physics. Is there any question about this question? Any doubt about this question? You are getting it, and the correct option is our option number A. That is y plus xy that we will what we get here. Okay. Okay. Okay, that's great. I think you understand that. So let's move to the second question. Now I will give you the time for 1 minute to try that question out. Okay. So here is the second question. This question is a little bit tricky. It will use the concept of spatial relativity of, right, and something like modern physics also. Okay. Sir, how to prepare short notes and what will be the way forward for the students who have completed the syllabus? I mean, why you are thinking about those students who has completed their syllabus? You should think about yourself, right? Don't care about others, what they had did or what they have not. You think about yourself, how your preparation is going on. Preparing short notes, just what the short note means, writing all the formulas that are there, right? All those formulas that you need to remember, you need to study before going to the exam. So write down all those things that you think you are not able to learn. That just prepare, take a single page, I mean 2 or 3 pages, just write all the formulas of particular subject there, all the concepts that are very important while solving the question. So these are the short notes. I prepared the short notes like that. That is enough for them. So try out this question. This question is little bit tricky. It will use the some special theory relativity as well as some concepts of modern physics. Okay, I'm giving you 1 2 minutes. Try it out. And all those questions that are like how preparation is going, how to do preparation or anything, we will take it after this in the session. After this questions, all the questions. Okay, I will give you the time. So now for that, let's focus on that. Okay, I hope you read the question. Let's start the question. So this question says that muons are produced through the annihilation. What do you mean by annihilation of particles? uh, Annihilation means when two particles collide and they form a single particle, right? When an particle and antiparticle, right, meet, that is the annihilation. And there is one thing like pair production. Pair production is like when an photon comes and interact with the nucleus, it will produce an electron and positron. So that is known as pair production, right? It means production of particle and the antiparticles. These are the pair production. What do you mean by annihilation? Means it is like collision of particle and antiparticles. So this is the annihilation. This just opposite of the pair production. So don't just confuse with these things. Okay, and this is known as annihilation. What the question says is, um, there is a particle A and there is an antiparticle A bar, namely this process. This is the pair annihilation, right? Here the particle and antiparticles are colliding each other. So this doing this reaction, they are producing muons. These are the muons. I mean mu positive and mu negative. A muon has a rest mass of 105 mega electromoles. Rest mass of muon is given. That is 105 mega electron volt per c square, and its proper lifetime. It is a proper lifetime. That is 2 microsecond. So what the data is given as mass of the rest mass of the muon is given, right? Rest mass of muons are given. That is 105 mega electron volt per c square. And one thing is the proper lifetime is also given, right? So what the proper lifetime is? It is 2 microsecond. That is 2 into 10 raised to power minus 6 seconds, right? Now an interesting thing is given. Here is the center of mass energy collision is given. So what do you mean by center of mass energy? In the lab frame that coincide with the center of mass frame. I mean by the meaning of the center of mass energy is when these muons are produced. When these muons are produced, the energy of both the muons are given. Just understand this thing is energy of both the muons are given with respect to the lab frame. That is 2.1 giga electron volt, right? 2.1 giga electron volt. Okay. So, but we then the fraction of muons that decay before they reach a detector. Now we need to find the fraction of the muons that will going to decay. By means of fraction, when you read this line, fraction of muons that they will decay, what concept comes in your mind? I mean, which concept comes in your mind? Radioactive decay, right? So what's the equation of radioactive decay? That is n equals to n naught e to the power minus lambda t, right? N naught e to the power minus lambda t. Great. So we need to find the number of muons that are not decayed, sorry, that are decayed before they reach a detector, right? So when we talk about radioactive decay, what this n means? N is the number of um, muons, or we can say number of particles that are left undecayed. Okay. And what we do if we want to find the number of particles that decayed, we just subtract that left minus total number of particles, and it means we can say we will do n naught minus n, right? Yeah, great. So these are the number of particles that gets decayed, and we need to find the fraction out of there. Then we just divide it by n naught. Then we will just divide it by n naught. Okay. And they said the detector is placed at 6 kilometers away from the interaction point. I mean, 6 kilometers away is the distance between the particles that are going to decay and the detector is 6 kilometers. So what's this? I think you read the question, right? You understood the question. What we need to find here and what are the data is given. Now can you find it? What are the steps that are going to we need to do? Anyone? What are the steps that we need to do? Okay, let me go through that. So here it is given that rest mass is 105 mega electron volt per c square, right? And energy is given. Energy, what's the energy is? Here energy of 2.1 giga electron volt. And what the meaning of 1 giga electron volt is? It is 10 raised to power 3 mega electron volt, right? So energy is given as 2.1 into 10 raised to power 3 mega electron volt, right? And this is the energy of both the muons, and both the muons have this energy total. So what is the energy of single muon? Just get divided it by 2, right? This is the energy of single muon, right? So we need to find that energy. What the form of energy? That it is like gamma m naught c square, right? This is the concept that you learn in the special theory of relativity, right? Great. If we somehow find out the gamma here, we can find out the velocity. Can we find out the velocity, right? Right. So let's find out the gamma here. So gamma is equals to energy upon m naught c square, right? So what is the value of m naught c square? That is simply 105. That is mass. So energy is 2.1 into 10 raised to power 3 upon 2 into 105. This is the value of gamma. Just calculate it and tell me what we will get here. Use the calculator. Let me do it with the calculator. That is simple, na? There is no need of choosing calculator. I mean, just divided with 2, and the power we will get is, I mean, 1.05 into 10 raised to the power minus 2 in the mega no, there is no any term mega because this is also in mega electron volt. This mass is also in mega electron volt, so it will cancel out. Okay, this will be the going to be value of gamma. Can we find out the velocity from this? Can we find out the velocity through the value of gamma? 1 upon under root of 1 minus v square upon c square. That is equals to 1.05 into 10 raised to the power minus 2. Okay, so just find the value of v from there. Just find the value of v from there. What we will get? Tanish Khilari says using calculator. I know this. There is no need of calculator, right? There is just simple calculation. Though. Find the value of v from there. It is something like 0.99 something, 0.99 c, 0.99. It will approximately we can take it as a c. Okay, it will come out to 0.999 something. Okay, we will. I am taking approximation as c. Okay, so what is the time taken by the muons to reach to the detector in with respect to left frame? So time that I want to find the time taken by muons to reach detector, right? We need to find that because we need to find the value of lambda, and also in the equation of n equal to n naught e to the minus lambda t, there is also a t also, right? So we need to find the time taken by the muons to reach the detector. So distance kitna hai? There is distance by speed. So what is the distance? That is 6 kilometer. 6 into 10 to the power 3. And what is the velocity? That is approximately c. So we are taking 3 into 10 to the power 8. Okay. So what's the time here? Just calculate the time. That is 2 into 10 raised to power minus 5 seconds, right? This is the time taken in the lab frame. And we are also in, is your lecture going to be recorded? Yeah, it is recorded. It will available to you after the live stream will all gets over also. Okay. This is a time taken by the muons to reach the detector in the lab frame. Okay. Now we will need to calculate. We are also given the proper lifetime. That is also known as mean lifetime in the rest frame of the muons. It is like 2 into 10 raised to power microseconds, na? 10 into 10 to the power minus 6 seconds. Right. This is the proper lifetime, or we can see mean lifetime in the rest frame of the muons. Mean lifetime. Okay. So this is the mean lifetime, and we need to find, but we need to find the dilated time. This is the proper lifetime in the rest frame, and we need to find the dilated time, I mean in the mean lifetime in the left frame. So how we are going to use it? We will going to use the Lorentz transformation, that is tau equal to tau naught into gamma, right? This is the value dilated time. And what is the value of gamma here? We have found out, na? This is the value of gamma. So just use it. 2.1 into 10 raised to power 3 upon 2 into 105. Um, I think there is a mistake. This is not 10 raised to 5. This is 105. So okay. So there is a mistake here. This is not 10 raised to power. This is 105. Okay. Correct there. So this is 2.1 into 10 raised to power 3 into upon 2 into 10 raised to power, sorry, 105, right? Into what is the value of tau naught? That is 2 into 10 raised to power minus 6 seconds. So what we are going is, so what we get, find out, it is going to be approximately equal to 2, and it will going to be like 2 into 10 raised to power minus 5 seconds. Approximately it is like that. Okay. So now we will need to find how much the particles that get decayed, how much fractions that get decayed, right? So let's find out that. As we know from the radioactive decay that n is equals to n naught a to the power minus lambda t. And if we are given with the mean lifetime, so what is the value of lambda? That is 1 upon tau, right? So we can replace the lambda from here. We will get n equal to n naught a to the power minus t upon tau. So what was the value of t that we found out? It is approximately 2 into 10 raised to the power minus 5 seconds. And what is the value of tau that we get? That is the mean lifetime in the rest frame of the muons. I mean in the left frame of the muons. That is also 10 raised to the power minus 5 seconds. When we put both these values in this equation, what we will get, that is n is equals to n naught a to the power minus 1. And we need to find out the fractions, that are number of fractions that get decayed. So as I told you that n naught minus n upon n naught, these are the number of fractions or the muons that get decayed before reaching the detector, right? So what is that going to be? N naught, what is n? That is n naught e to the power minus 1 upon n naught. So it is n naught 1 minus 1 upon e upon n naught. So this gets cancelled out. It will become 1 upon 1 upon e. So just find it the value. I mean, if we see the options here, we are having like this. The option number B is going to be correct. Okay. So correct option is B. So fraction that get decayed is 1 minus e to the 1 minus e. So let's move to the next question. If you have any doubt, is there is any doubt that you are having it, just drop in the comment section. No, I think it is B option, na? It is B. 1 minus e to the minus 1. The answer was 1 minus 1 upon e, so we will do 1 minus e to the minus 1 is the answer. So correct option is option B. So let's move to the next question. Just read the question. Any doubt in the previous question if you are having it? कोई भी doubt हो तो पूछ सकते हो उस previous question में. Otherwise, let's move to the next question. Just read the question and try to solve it. I mean, this is also based on the Cauchy-Riemann equation. I mean, the complex analytic. Same equation we are going to use in this question. It is B. Yeah, that's great. It is B. You are quitting fast, Aditya. Great. Okay. This is easy one question that okay. So u is the function of xy is given to us. That is equals to e to the power ax cos by, right? And here what we need to do is we need to find the condition for the complex function to get the to be analytic, right? So we will again apply. I didn't see the options correctly. I mean, which question you are talking about? I mean, this question or the previous one? Okay, so let's move. So here what we are going to do is apply the Cauchy-Riemann equation. So del u upon del x is equals to del v upon del y. And what was the second equation? That is del u upon del y is equals to minus of del v upon del x, right? So when we partial differentiate with respect to x, what we will get? That is e to the power ax cos by is equals to okay del v upon del y. And if we see here, if we apply this equation, let's differentiate u with respect to y. What we will get? We will get b e to the power ax sine by, and the negative sign will also come here because derivative of cos is minus sine, and we will get del v upon del x, that is minus, right? So if we solve this, we will get b equal to e raised to ax sine by equal to del v upon del x, right? We get this equation, and from here we get this. And we know that if these functions are analytic, so partial derivative u with respect to x and y, I mean partial derivative of v with respect to x and y will also become equal to partial derivative of v with respect to x and y, right? So let's differentiate this equation with respect to x also. Let's differentiate with respect to x. We will get here we will get a square e raised to power ax cos by, right? So here we will get del v upon del x and del y, right? If we again differentiate this with respect to y, we will get b square e to the power ax cos by, that is equals to del v upon del y and del x, right? We get these things. So if you see the right hand side, the right hand side of both these equations are equal. So we just going to compare this both the equations, and we'll find the what could be the possible values of a and b. So let's just equate these two values. The first equation gives us that a square e to the power ax cos by is equals to del v upon del x del y. And what was the second equation? It was like b square e to the power ax cos by. It will also equal to del v upon del y del x. Right? Just equate both these equations. What we will get is a square e to the power ax cos by is equals to b square e to the power ax cos by. Right? Both these terms gets cancelled out, and we will get a square equal to b square, and we can now write a is equals to plus minus b. Right? We need to find the values of a and b. What could be the values of a and b? So a is equal to plus minus a and b. Right? And if we see the option, so option number b is correct. Getting it? If you have any doubt related to that question, you can ask me right now. Is there any doubt related to that question? We just use the simple Cauchy-Riemann equations. What the Cauchy-Riemann equation says, that the partial derivative of u with respect to x and partial derivative of v with respect to y are equal. Partial derivative of u, that is the real part, of u with respect to y is equals to minus of partial derivative of v with respect to x. So these are the two things. Is there any question or any doubt you are having about this question? I think there is no any doubt. So I think it's all clear to everyone. So let's move to the next question. So this question is related to EMT, or you can say it is a somewhat related to EMT and somewhat related to modern physics. Here, what we need to find is we need to find the magnetic moment of an electron moving in a circular orbit, moving in a circular orbit of the radius r about a proton. As we know, in any atom, there is a nucleus at the center, which contains a proton, and an electron is revolving around this orbit, right? So what we need to find? We need to find the magnetic moment. I think everyone knows about what is the magnetic moment, right? Magnetic moment is just like I into A. That is, if there is any current loop, if there is any loop in which some I current is flowing, then magnetic moment is just the product of this current and the area of that loop. That is the magnetic moment. So here we need to just find out the magnetic moment when an electron is revolving around the proton. Okay, try this out on your own. Then I will do it for you. कोई ट्राई कर रहा है इस क्वेश्चन को? Okay, so let's start. I think we need to hurry up. So here the magnetic moment is just current into area. What is the value of current? That is charge flowing in the loop upon time period, right? Into pi r square. Let's say the radius of this orbit is r. We are getting like this. So what is the time period actually is q upon, that is 2 pi r, that is distance traveled upon with the speed v. Let's say the speed is v, right? Into pi r square. We get q into v upon 2 pi r into pi r square. Here we get qvr by 2. But I think the options are not matching. Why it is not matching? Here we need to substitute the value of v, right? So as we know, whenever the electron is revolving around the orbit, some centripetal force is acting on it. Centripetal force is acting on it. What's that is? That is proportion to mv square upon r. This is the centrifugal force, right? It is equal to the force acting between the proton and the electron. That is k, right? E square upon r square. This is the force acting on the between the proton and the electron. If this distance between them is r, so k into charge of proton, that is E, into charge of electron, E, and divided by the square of the distance between them. So this is the equation, that the centripetal force is equal to the force between the electron and the proton. So what we get the velocity as? Let's derive the velocity from here. So we get v square equals to k e square upon r, and here will m, right? So v is equals to under root of k square upon m r. So just put the value of v here. We will get the magnetic moment. What's the magnetic moment is? We will get e square upon 2 under root of k r upon m, right? We will get this because this r when comes inside the square root become r square, and 1 r and r square will cancel out, and we will get r in the numerator. So what is the option we are getting out? E square by 2 m k r upon m. So option number C is correct. Is there any doubt about this question, or you anything you want to ask from this? Concept is clear, right? Great. So there is no any doubt, no any comment there. Okay. So let's move to the next question. Read out the question. Yeah. It is belonging to the modern physics. So the question says that here is a X-ray spectrum. X-ray spectrum of a cobalt. The atomic number of cobalt is 27. Contains a strong K alpha line of the wavelength 0.1785 nanometer. Okay. And a weak line having a wavelength of 0.1537 because of an impurity that is into it. We need to find the atomic number of that impurity element, right? We need to find the atomic number of that impurity element. Can you just try it out yourself? It is easy. I mean, the simple formula, like we know 1 upon lambda is equals to r infinity z minus 1 square initial minus 1 upon m final square, right? For as both the wavelengths are for the k alpha line, so these things is equal, and when we take the ratio, it will get cancelled out. It will only depend on this factor z minus 1 square, right? So we need to find the atomic number for the impurity element. Wavelength for both the given, right? Both is given, right? So if we get out the wavelength of cobalt upon wavelength of the impurity, let's say denote by im, we will get z of impurity minus 1 square upon z of cobalt minus 1 square. Okay, great. So Z of, I mean, atomic number of cobalt is given, wavelength of cobalt is given, impurity of cobalt is given. We just need to find the atomic number of impurity element. It is easy, right? So just put the values here. Wavelength of cobalt, that is 0.1785. Wavelength of impurity, that is 0.1537, is equals to Z of impurity element. We need to find Z of cobalt is 27, so 27 minus 1 square. Just find the value of Z of impurity, what it is coming out. Find out that fast. It will come around 29. Just verify the answers. I mean, this is the basic math. I'm not going to do it. I hope you will did it right. It will come out 29. Any doubt in this question or anything you want to ask? Okay, I think it's clear. So let's move to the next question. The question number 6 says that let ES denotes the contribution of the surface energy per nucleon in the liquid drop model. Right? We are having a liquid drop model, and ES is the surface contribution surface energy. If you see the binding energy, if you know about the liquid drop model, have you studied in the modern physics, right? You should have studied it. It will contain some volume element, surface element, symmetric part, and the pair energy part. Here we just need to take the surface part, right? What this says is surface is directly proportional to the area, right? This is the A is the area, right? Let me do it, area. Or we can say it is directly proportional to R square, or we can say it is A to the power 2 by 3. And what is the A here? A is just the mass number. Mass number. It is like 2 by 3. As we know, R is equals to R naught A ki power 1 by 3. So R square will be A ki power 2 by 3. Right? And it says that binding energy, surface energy per nucleon. This is the term corresponding to surface energy. If you want to surface energy per nucleon, then we need to divide it by A. So what we will get here? We will get A to the power 1 by 3. Right? And we just need to find the ratio of these things. Right? Ratio of these two terms. So ratio for ES, and it is binding energy surface per nucleon, for aluminium 27 and 13 upon ES for 64 Z and 30. So what we will get, that is 27, that is the mass number, 1 by 3 upon 64, 1 by 3. It will come out to be it will like 3 upon 4, right? So the ratio is going to be, so sorry, it is minus 1 by 3, right? It is minus, so it will be like minus here, minus here. Just need to take the reverse. It will come out to 4 upon 3. So the correct option is B. That is 4 ratio 3. Just very simple question, but it is trickier. Sometimes it is not getting into the mind. It doesn't click into the mind. So I'm think it is should be the good question for that. So let's come to the question number 7. This question says that assume that uh, the energy of the two particles in the field of each other is given by U of r minus alpha upon r plus beta upon r to the power 8. where alpha and beta are the constants. R is the distance between the center of the particles. Okay. In a stable configuration state, the ratio of the energy of attraction to the energy of repulsion, we have to tell that. But we will be going to the ratio of energy of the attraction to the ratio of energy of the repulsion, right? U of potential energy is given as that. For a stable state configuration, as we know, that del G upon del R should be equal to 0, and del to U upon del R2 should be greater than 0, right? For a stable state configuration, we need to find the minima, right? Because if we have system like this with potential energy like this, if the particle is there, then we will go do oscillation back and forth. It is stable, right? So that these are the condition for the stable equilibrium. So let's do the partial differential with respect to R and put it equal to 0. What we get is we will get alpha upon R to the power square minus 8 beta upon R to the power 9 equal to 0, right? So just find out the ratio between R, alpha and beta. What we will get here, alpha upon R square equal to 8 beta upon R to the power 9, right? So from this we will get R to the power 7 equal to 8 beta upon alpha, right? So R is equals to 8 beta upon alpha to the power 1 upon 7. Getting it? Great. So now we need to find the ratio of attraction to the ratio of energy of repulsion. So if you see the potential energy term carefully, there is a two terms. The first one is the negative and the second one is the positive. And we know that the negative part contribute to the attraction part and the positive part contribute to the repulsion, right? We need to find the ratio of the required ratio. What will you get? Ratio is beta, that is ratio of attraction, na? The first is ratio of attraction, so we need to write alpha upon R. Just do like this. It is minus alpha upon R upon beta to the power R to the power 8, right? Just find this ratio, we get alpha upon beta R to the power 7, right? Put the value of R from, take the R from there, we will get it, the answer is 8, because beta and alpha gets cancelled out and we will are left with the 8. Here is the 8 answer. Okay. Is there any doubt in this question? Hmm. I think it is not clear to you due to my okay, let me do it sideways. So the ratio is going to be like alpha upon R upon beta to the power R ki power 8. It will like alpha upon beta R ki power 7. Just put the value of R from here. Alpha and beta gets cancelled out and we are just left with the value of 8. Okay. So that is the thing. Let's move to the next question. That is question number 8. What this question 8 says that for a large mass number A, it is found that the binding energy per nucleon, it's like binding energy per nucleon is 9.402 into sorry minus it is like 9.402 minus 7.7 into 10 raised to power minus 3 into A here. So this is the binding energy per nucleon given. So, okay, given that binding energy of alpha particle is 28.3 mega electron volt. The value of A above which the emission is observed. We have to find the value of A for which this alpha particle, this emission is observed. I mean alpha decay gets observed, right? As we know, when the alpha decay gets observed, when the q value, that is the q value is greater than 0, right? When the q value gets greater than 0, we can get the alpha decay, right? So what is the reaction for the alpha decay? If I write to, let's say we have a particle X having atomic numbers Z and A, mass number A, it decays to a daughter nuclei having Z decays to by 2 and mass number decays by 4 plus alpha particle. Here is the alpha particle and some q value, right? When this q value is greater than 0, we can get an alpha decay, because for alpha decay, the q value of alpha decay is always greater than 0, right? So what is the value of q? That is binding energy of the product minus binding energy of the reactant. Binding energy of product minus binding energy of the reactant, right? So we have a binding energy, right? Binding energy given by this formula. So binding energy of product is 9.402 minus 7.7 into 10 raised to the power minus 3. Now in place of A, we have a mass number A minus 4. We will just put A minus 4. Getting it? This is the binding energy per nucleon, and we will multiply with the mass number also, because we need to find the binding energy. But this is the binding energy per nucleon. So 1 A minus 4 has to be multiplied. This is the mass. Similarly, we will do it for the reactants. So what is the binding energy of the reactant having mass number A and atomic number Z? This is similar to 9.402 minus 7.7 into 10 raised to a minus 3 into A, right? Because mass number is A, and this is the binding energy per nucleon. So we multiply an extra A because we need to find the binding energy. Okay, right? So let's find out that. Solve this expression. I mean, simplify this expression. What we will get is 9.402 A minus 4, right? And there will also come at plus binding energy of alpha particle will also be there, because alpha particle is also in the product, na? So we need to add that also. It is constant, right? That is 28.3 mega electron volt that is given to us. Just solve this expression and put q greater than equal to 0. I mean, not going to solve this because this is a lengthy, I mean, it will take time. So we don't have enough time. Just put q greater than equal to 0 and find the possible values of A. Okay, what we will get here? So q is greater than equal to 0 will give us A greater than equal to 153. Okay, any atom having its mass number greater than 153 can have possibility of alpha decay because q value is greater than equal to 0. So the correct option is 153. So where can we find out the mock test papers for JAM? I mean, there are multiples. I mean, for mock test, you can look at the test series, any coaching center test series. You can, I mean, for MasterPath, there is a separate test series, right? There also for you look at whichever you prefer, you can give a test series, because you need to practice for that. You need to know how much you can handle the time pressure while doing solving the question. How much time you need to you can give to a single question. Okay. Or one thing you can do is take any paper, take any previous year paper, take a stopwatch from there also, took an alarm of 3 hours and try to solve these questions. You can do that also. So here is the question number 9. भैया मेरा इलेक्ट्रॉनिक्स थर्मोडायनेमिक्स मॉडर्न हो गया है. ओके गुड. एएमटी और कवर कर लो. इट इज इंपॉर्टेंट ऑल्सो. इलेक्ट्रोमैग्नेटिज्म बहुत क्वेश्चंस आते हैं उसके अंदर से भी. In terms of arbitrary constants a and b, the general solution of the differential equation, this is the differential equation, right? And we need to find the solution of this differential equation. As you can see, this is the second order differential equation, and also you can get a hint, right, when x square is multiplied with d2y by dx2. So here what we do is we will consider that x is equals to e to the power z, right? Because here is a x square term, we can't directly solve it. We need to do some substitution. We need to convert into some another variable, then put the value of that variable with respect to x, and we will get the solution, right? So let us try to put x equal to e raised to power z. If I take log both sides, we get ln x equals to z. And if I want to find dy by dx, what is the value of dy by dx? We get dy by dz into dz by dx, right? So what's the value of dy by dz? Let's put it, and we need to take this differential equation into in the format of dy by dz, right? So we can't put it directly, we don't know the value of dy by dz. We can find the value of dz by dx. If we want to find the value of dz by dx, it will come out to be 1 upon x. So just put the value 1 upon x dy by dz. Okay, so from here we can find out the value of dy by dz, x dy by dx. Okay, just use this equation. Take the derivative of, now find d2y by dx2. Just take the derivative of this equation again. I mean, this is the dy by dx. Take the derivative of this equation again. We will find out d2y by dx2. It will come out to like minus 1 upon x square dy by dz, right? Plus 1 upon x d2y by dz2 into dz by dx, right? When we put the value of dz by dx, it will come out to be like this, 1 upon x. So our equation becomes minus 1 upon x square dy by dz plus 1 upon x square d2y by dz2, right? Now multiply it with x square, what will you get? Let's do it on the next place. So we get x square d2y by dx2 is equals to d2y by dz2 minus dy by dz, right? And what is the value of x dy by dx? From the previous page, we can see that the value of x dy by dx is just dy by dz. It will make our life easy, dy by dz. Just put these values in this equation. Our equation will become like this: d2y by dz2 minus dy by dz. Okay, and if you go 5, that is 5 dy by dz. Okay, plus 5 and plus 3. Okay, so this is plus and plus 3 equal to 0. Now we just need to solve this differential equations. That is d2y upon dz2 plus 4 of dy by dz plus 3 equal to 0. This is a simple second order linear differential equation. We can write it like d square plus 4 of d plus 3. I'm now going to find the complementary solution of this equation, right? Just find out the value of d here from here. What are the possible values of d from this quadratic equation? it will come out to be d equal to -3 and d equal to -1. So these are the two possible values of d that will come out from this equation. And if we get two different values of d, so what is the possible solution that we are going to get? That is c1, right? C1 is some constant, e to the power minus 3z, 3z plus c2 e to the power minus z, and just to put the values of z here. What was the value of z? We just find out, right? When we make the substitution, we find out the value of z as ln x. So in the place of z, just put the value of z as ln x. So what we get is, y is equals to c1 upon x ka cube, right? Because when you put ln x here, so 3 will come into the power of x and e will cancel out with ln. So we'll get 1 upon x cube because there is a minus sign also, plus c2 upon x, right? Where c1 and c2 are the arbitrary constants, right? So which option is correct? Option number D is correct. Is there any doubt in this question? Because this is a very basic question of the mathematical physics while solving the differential equations. That is the second order linear differential equations. Uh, साराभाई स्कूल ऑफ साइंस, ओके। अब क्या मैं पूरा पढ़ कर जाऊं या एएमटी के बाद रिवीजन करूं, या पूरा पढ़ूं? देखो, एएमटी आप इलेक्ट्रोस्टैटिक और मैग्नेटोस्टैटिक्स, ये दो टॉपिक्स को बिल्कुल अच्छे से तैयार करके जाओ, और अभी आपके पास टाइम है, एंड देन स्टार्ट रिवीजन, यू कैन डू इट, राइट? इलेक्ट्रोस्टैटिक एंड मैग्नेटोस्टैटिक दोनों पार्ट आप अच्छे से कर सकते हो, सो आई थिंक यू कैन डू इट. So let's move to the next question. This question says that an atom of mass m, there is an atom of mass m, and that can be excited to a state of mass m plus delta by a proton capture, right? This question says that there is a proton, or this is not a proton, this is a photon, right? So this is a mistake. There is a photon. Okay, Sarabhai, we will discuss it in the last of this session. I will give you the time here, but let's now focus on these questions. Okay, this is a photon, and here is a mass m. This photon gets struck with the mass m, and it will give us a mass m plus delta, right? And we need to find this frequency of photon. Let's say the frequency, initial frequency is h nu, and this gets absorbed with the mass m, and it will give us a mass m plus delta. We can apply the conservation of energy here. That initial energy of the photon was h nu, the mass m was at rest, so here we have mc square, right? M is the rest mass and c square is the rest mass energy, right? Is equals to mass of this, because it has some velocity, so we are taking the energy as, so we are going to take the energy as under root p square c square plus uh, m plus delta, that is the rest mass energy, c ki power 4, right? This is the energy part. M naught is the rest mass, so we take as m naught m plus delta. And if we apply the momentum conservation, what the momentum conservation says, that momentum of the photon, what is the momentum of photon? That is h nu upon c. This is the momentum of photon, and is equal to the momentum of this part, that is equals to p. Let's say the momentum of this m plus delta mass is p, so it will come out to be this. We have to solve both this equation, and we need to find the value of what could be the value of nu, that is the frequency. Just square both sides, but we will get h square nu square plus m square c ki power 4 plus 2 of h nu m c square is equals to p square c square प्लस यहाँ पे स्क्वायर आएगा बिकॉज एम नॉट स्क्वायर होता है ना, तो यहाँ पे एक स्क्वायर आएगा, तो सॉल्व दिस स्क्वायर एज वेल, दैट विल कम आउट टू एम स्क्वायर सी की पावर 4 प्लस डेल्टा स्क्वायर सी की पावर 4 प्लस 2m डेल्टा c की power 4, right? We will get this, and now just put the value of p here, right? But we will get, when you put the value of p here, so h square nu square plus m square c की power 4 plus 2 of h nu mc square equal to, put the value of p square, we get h square nu square, because c का square and c square from this will cancel out, and we are left with the h nu square and nu square plus m square c की power 4 delta square c की power 4 plus 2m delta c की power 4. So these two terms gets cancelled out, and we are left with 2h nu mc square is equals to delta square c की power 4 plus 2m delta c की power 4. We need to find the nu. So what is going to be nu? Just divide this, divide by this, we get delta c की power 4. Is this any mistake here? I mean, no. Delta c की power 4. I'm taking delta c की c power 4 as common, delta plus 2 of m, right? And we will get twice h m c square. So this will come out to be delta c square, delta plus twice of mass m upon 2hm. So this will be going to be the correct option. I think there is no any correct option. There is mistake in the question. So this is going to be the correct. The frequency nu will be this. Okay. Is there any doubt about this question, or should I move to the next question? No one is responding in the comment section. I think it's crystal clear to everyone. Okay. So let's move to the, without wasting any time. Yeah, this question is a little bit easy. This is the part of the statistical mechanics, or you can say statistical physics. A gas of n non-interacting particles. There is a gas of n non-interacting particle. It is in the thermal equilibrium at temperature T. Right? Each particle can be in any of the possible non-degenerate state of energy 0, 2e, and 4e. We need to find the average energy per particle. We need to find the average energy per particle, and what are the possible number of terms? That is this. Okay. So let's find what is the formula of average energy there. Right? That is sum of EI e to the power minus beta EI upon summation of e to the power minus beta EI. So what we call this term? This is known as the partition function Z. Right? So this term is known as partition function, and we just need to put the values EI, calculate the summation, and we get the average energy. So let's try to find out this average energy. Okay. So what our average energy becomes, that comes out to be, the first one is 0, that will 0 into e to the power minus beta 0, plus second one is 2 epsilon e to the power minus beta 2 epsilon plus 4 epsilon e to the minus beta 4 epsilon upon, here comes e to the power minus beta 0 plus e to the minus beta into 2 epsilon plus e to the power minus beta into 4 epsilon. The above, this first term becomes 0, second term is like 2 epsilon e to the power minus beta 2e plus 4 epsilon e to the power minus beta 4 epsilon. This will become 1 plus e to the power minus beta into 2 epsilon plus e to the power minus beta upon 4 epsilon. Right. So this is going to be our average energy of the system. Now we need to consider one thing, as the options are not matching, right? Options is not matching because there are some terms like exponential here, but there is no any exponential. So what we can take is, we can take the temperature of the system very high such that e to the power minus beta 2 epsilon will, I mean e to the minus beta will become approximately become 1. We can take the temperature is too high that this term will become 1. So what we'll get is 2 epsilon per 4 epsilon plus 1 plus 1 plus 1, right? That will come out to be 6 epsilon upon 3. That is going to be 2 epsilon. So average energy will become 2 epsilon. So the correct option is A. Getting it? So our correct option becomes A. So let's move to the next question. So here is the question number 12, which says that consider a crystal containing a paramagnetic impurity. So this is a question from the thermodynamics also. Okay, statistical physics. But here is says that containing a paramagnetic impurity, something like a solid state physics is there, but the concept, purely concept of thermodynamics is there, whose energy levels are plus minus epsilon in a given magnetic field. We need to find the specific heat of that crystal. We need to find the specific heat of that crystal at high temperature. Temperature is very high. So what is the value of C? We know that is del G upon del T, right? At constant volume, right? So if we somehow find the value of U, we can calculate the CV, right? We can calculate the specific heat. So by using C, how we are going to calculate the U? That is, we can write like KBT del upon del T, right? Into ln Z. As we know, it is from thermodynamics. If we somehow find the value of Z, can we find out the value of U, right? Or I can also write it like that. Okay, let me find out the value of Z as well. First, let me find out the value of Z. So what is the value of Z? There are two energy levels. So one is plus E and one is minus E. So it is E, E exponential beta plus E to exponential minus E beta, right? Getting it? That is cos hyperbolic epsilon beta. Can we write this? Can we write the value of U in terms of beta? Can we write the value of U in terms of beta? Yes, we can. We can write the value of in terms of beta, that is del upon del beta ln Z, right? It is something, it should be like kbt square. Yeah, there's a mistake. So we can write this, or we can say it is del upon del 1 upon kbt ln z. So what is the ln z? It is like 2 cos hyperbolic epsilon b. If we find the value of ln z, that will come out to be ln of 2 cos hyperbolic epsilon into beta, right? If we take a derivative with respect to beta, like u is something like del upon del beta ln z. So take the value derivative of this part. It will come out to be something like tan hyperbolic. It is tan hyperbolic cos and then cosine. So it is sine upon, yeah. So it is tan hyperbolic epsilon into beta into में epsilon एक term आ जाएगा, right? And if we again so to find the specific it, to find the value of specific it, we need to derive this. We need to take a derivative with respect to temperature of u, as we can write epsilon tan hyperbolic epsilon upon kBt, right? If we take the derivative with respect to temperature, the term will come out to be like it will 1 upon t square. When you take the derivative of this term, come out to be 1 upon t square, or we can write c is directly proportional to t की power minus 2. So option number c is correct, right? Because if we when you take a derivative, 1 upon there's a term called 1 del upon del t, 1 upon t will come out, and we just need to find out the dependence of temperature now. So we can just do it fastly, and we don't need to calculate the whole value of c there, right? Anybody have any doubt in this question? Okay, so let's move to the next question. This question says that X-ray, there is an X-ray reflected from a simple cubic crystal. I hope you have studied the concept of Bragg diffraction, right? Right. So if the density of crystal is measured in the RMS error, so density of crystal is given as 3 parts in 10 raised to the power 4, and if the angle made by the incident reflected ray make with the crystal plane is 6 degree, right? I mean the theta incident angle is 6 degree, and the measured with an RMS error, root means square error, with 3.4 minutes of an arc. Then what is the error in the determination of the wavelength? We need to find the error in the determination of the wavelength. How we are going to do this? So it is simple, like for a simple cubic crystal, for a Bragg diffraction, we get the condition like 2d sine theta equals to L lambda, right? 2d sine theta equal to L lambda. Let's take a log both side. Taking the log, we get ln 2d sine theta equal to ln n lambda. For first order reflection, we can take n equal to 1. So when we put n equal to 1, we get ln of 2d plus ln of sine theta equal to ln of lambda. Take a derivative both the sides, we get delta d upon d. And delta d is the change in value of d. Okay, plus here we get sine theta cos theta upon sine theta into delta theta equal to delta lambda upon lambda, right? Delta lambda, we can say there is a error in the measurement of the lambda. Getting it? So we just now put the values, but before putting up the values, we need to find the value of delta d upon d. As we have information about theta and delta theta, we need to measure delta lambda upon lambda, right? But we don't have any information about this part. We need to find. So how we are going to find that? Let's see. We are giving something like change in the density part. I mean, we are given with the density and the change in the density, that is 3 into 3 upon 10 raised to minus 4. That is something like 3 in 10 raised to power 4. So that will come out 3 into 10 raised to power minus 4, right? So how we are going to relate the D and the rho, right? As we can see that rho is like n is the effective number of atoms, m is the mass of one atom upon now we need to calculate the volume. So it comes out like dq and Avogadro number. I don't need Avogadro number because we have n here. M is the mass of one atom. So if we take d cube, we need to find the d cube here. D cube equals to n m upon rho. Take the derivative both sides. I mean take the ln and then take the derivative. By taking the log both sides, we get 3 of ln d equals to ln n into m minus of ln of rho. Take the derivative both sides because n and m are both constant. N is the effective number of atom in a single cubic cell. M is the mass of the atom, single atom. So both are constant. There is no any error measurement there. So we can take while derivative, this will goes to the zero part. So we are left with 3 delta d upon d equal to minus delta rho upon rho. Whenever we find the error, we need to take it as absolute. So 1 upon 3 delta rho upon rho. Just take the absolute error and it will become plus, right? Yeah. So delta rho is rho upon given. That is, we just find out that it's 3 into 10 raised to minus 4. It is something like if we calculate 10 raised to minus 4 comes because 1 upon 3 into 3 will gets cancelled out and we are left with the 10 raised to minus 4 like this. And in the previous page, we have seen that this equation, right? If we need to find the out the RMS error in the wavelength measurement of the wavelength, how we are going to find out? The formula for this is like discuss square and plus discuss square, right? That is delta d upon dk square plus sine, sorry, cos, it is cos theta upon sine theta square and delta theta square, right? So this is the RMS error in the measurement of wavelength. So we know the value of delta d upon d, right? And we know the value of theta and delta theta as well. Delta theta is just 3.4 minutes of an arc. But if you see that if we're going to scale the atom, like delta d upon d square is like 10 to minus 4 ka square, going to be approximately like 10 to minus 8. This is a minus sign, right? And it is a very negligible term. We can take it as a negligible. So what we are left with delta lambda upon lambda is cos theta upon sine theta delta theta, right? Taking the small angle approximation, we can write this term as theta cos theta is something like 1, right? When the angle is small, it will look like 1. Cos 0 is approximately equal to 1 and sine theta is approximately equal to theta into delta theta. So we can write it as delta theta upon theta. So what is the value of delta theta? If you see, it is given as 3.4 minutes per hour. We need to convert it into the degrees because theta is in degree. So 3.4, it is in the minute. So to convert it into the degree, we need to divide it by 60 and theta is given as 6 degree. So let's find out this. What is the value of this? It is just come out to be 9.4 into 10 raised to the power minus 3. This is the error that we are going to get in the measurement of the lambda. Okay. Are you getting that question? Or is there any doubt that you want to ask in this question? Is there is any doubt? Sir, in these questions are from yeah, some of these questions are from just if TFR TFR. It is from TFR PYQ. This question is from TFR because I found this a very interesting question. This concept is from error handling, right? So do you have any doubt regarding this question? I mean, question number 13. You need to digest it a little bit, or should we move to the next question? Okay, I'm moving to the next question. Okay, great. So the next question is like a deuteron of mass m and a binding energy B is given, is struck by a gamma ray photon, right? Here is a deuteron, let's say it is 1h2. It's struck by a gamma ray photon having energy E of gamma and is observed to disintegrate into neutron and proton. It will disintegrate into neutron and one is proton. Here the binding energy is given at very well less than mc square. We have to find the value of E gamma. What could be the minimum value of E gamma? I think you all have did the concept of threshold energy. That is the minimum energy required to the target that we need to give to the target to make the reaction happen, right? Some reactions have the positive Q values. Some reaction have the positive Q values. So we need to give the energy first to make the reaction happen. So this is the question of that threshold kinetic energy. How much energy we need to give to before for that reaction so that reaction can happen. Right, we need to find the E energy of gamma. Where the Q value question, right? We know what is the value of Q in terms of binding energies. That is the binding energy of product minus binding energy of the reactant, right? As you can see in the product, there are two particles. One is proton and one is neutron. And as we know that there is no any binding energy for the protons and neutrons because these are the particles, right? So how we can find out the Q values? It is just any binding energy of the neutron plus binding energy of protons minus photon does not have any binding energy, so binding energy of the deuteron, that is 1h2. As also a neutron and proton are particles, so binding energy of neutron is 0, binding energy of protons are going to be 0. So we are just left with the binding energy of deuteron, that is given as to be B. So we have a Q value as B, right? Right, getting it. So now what can we do now? There is also, we can write Q value in terms of the mass of the particles. That is the mass of the reactants minus mass of the products, right? We can calculate that part. We can write Q value as equals to a mass of the reactant, that is mass of the photon mass is 0, so mass of the deuteron 1h2 minus mass of the neutron and proton, so mass of neutron plus minus mass of proton into c square. So now we can find out mass of deuteron is taken as m and mass of neutron I can taken as mn and mp c square. Okay, now for the threshold kinetic energies, we kinetic energy of the gamma particle, that is the threshold. We need to give energy to the photon. So that come out to be E of gamma is equals to minus of Q value is into, here there is a formula like sum of all the particles involved. Sum of all the particles, you can say sum of all the reactant and products, right? All the particles all particles present upon twice into mass of the target particles. Mass of target particle. So what is the target particle here? Target is the this deuteron atom. So what is the mass of? Mass is m. So we just need to calculate this threshold kinetic energy, which is the energy of the gamma particle. That is the minimum amount of energy we need to require. Just the reaction can happen. So energy of the gamma particle is going to be minus of q value upon what are the masses that are in the total in the reaction. Mass of the photon is 0. So there is a mass of the deuteron plus mass of the neutron is there. Sorry, mass of proton and neutrons are there upon twice of m. But if you see the options, there is no any, I mean, there is no option, sorry. So we need to find the energy of gamma particle. So energy of the photon. This can also be the answer, but if we want to represent in terms of the binding energy, we can write it like this. Q is minus B, so B into mass of proton plus mass of neutron upon twice of mass. If we compare these two results, like the Q value we get from here and Q value we get from here, we get like mass minus mass of neutron minus mass of proton. Like this is the mass of proton is equals to minus B upon C square. Now if we want to find out the mass of neutron and proton, we can substitute it like this. Mass of neutron plus mass of proton is equals to M plus B upon C square, right? So if we go down and put the mass of proton and mass of neutron is equals to, we get B into, we get M plus B upon C square upon twice of M. We get B into